Hey there, everybody. Welcome back. We are in the middle of geometric optics, and today things are really going to get fun. This is where the craziness really starts to kick in. So, hope you enjoy. Um, Here's what we're going to try and do today. We're gonna talk about some general things about curved mirrors, and then number two, we're going to talk about how one kind of curved mirror, a concave mirror, makes an image. Okay, definitely need a fair amount of paper today. Um, a straight edge, and I'd probably use some colors as well. There's going to be, I expect, a lot of time you're going to need to be catching up on your drawing while I'm talking. So be ready with that pause button as well. Um, this is one of those where yeah, lots of drawing. So let's start off. Here we go. Review. Remember reflection. That's pretty easy. The angle of incidence equals the angle of reflection. We saw that. So that was nice. Now, here we go. We're going to talk about two kinds of curved mirrors, convex and concave. Let's cover convex first. Notice if it's on the left, if we have light coming from a very distant source, the sun or a star or a tree really far away, they're basically coming in straight and they're going to bounce off. Wherever they hit that mirror, they're going to bounce off with the angle of incidence equaling the angle of reflection. Okay, so a convex mirror, excuse me, will bounce the light out, and then part B on the right over there, a concave mirror will bounce light in. All right. Remember, the law of reflection still holds. Angle of incidence equals the angle of reflection. Okay. So a couple things. Here's our first one here. We're going to talk about concave mirrors. Now, here's how you remember. A concave mirror looks like a cave. All right. So it looks like you're shining light into a cave. It's curved kind of in towards you. So a couple little things. A concave mirror has two things we gotta be aware of: a focus and a radius. Okay. So real quick, a couple things that you gotta be careful of. The focus is labeled as little f. So what we do is we draw. It's like we cut a slice through the middle of the mirror, and we draw a dotted line down the axis of that mirror. And along that line, we put the focus and the radius. Now the focus is little f. Here's where you need to be careful. We also have used frequency of a wave to be little f. Okay? When you see images and mirrors and stuff like that, f usually means the focus or the focal length. Okay, so the point is f, but the distance from the mirror out to f is also labeled f, and it's the focal length. Okay, they're pretty easy to tell apart. F focus, f focal length. So one is a distance and one is a place. R is the center of curvature, and the big R distance is called the radius of curvature. So focus, radius, things like that, when we talk about them, we're either talking about the point or the distance. All right. Something very important for all the mirrors that you're going to see, here's the rule. F equals half of R. R divided by 2. Okay? So when you have a spherical mirror, you might also see that. Okay? Our mirrors will be spherical. Or if they say it's a concave mirror, or a convex mirror for that matter as well, we'll get to that in the next lecture. But here's the rule. Focal length equals R over 2. Now, that's on your equation sheet for the AP test, so you don't need to remember that. but it is a rule. They might just leave those off or give you one of them and expect you to remember or be able to find the other one. Okay? So focus or focal length and radius. Now we're gonna take a step away from those terms just for a second, and then we'll come right back to them. Okay? So don't freak out. Let's talk about how we see something when we have a concave mirror. So here's what I've done. I have a cat, and my eye is down below the center of the mirror, and I look into the mirror and look at the cat. The tip of the cat's tail has a whole bunch of rays coming out from it. Those rays hit the mirror in all different places, and they all will come together at one spot. And when I look into the mirror, I will see the cat upside down and little if the cat's standing where it is now. Okay, now notice, there's rays flying out all over from the tail of the cat. Only some of them go into my eye. But what that means is that if I can see the cat in the mirror, I could put my eye anywhere. I could move it up a little bit or down a little bit or back and forth. And all those rays look like they're coming from exactly the same spot. Okay? They look like they're coming all from that spot right there. Okay? So it seems like that's where the cat is in space, upside down and right there. Okay? So here's what we're going to do to figure out how to make these images. This is the part where you really need to draw. All right? Well, soon. Not quite yet. We're going to focus on 3 special rays that are coming out from the tail of the cat. Okay? Notice the top 2 rays go right through the focus, and the bottom ray goes right through the radius of curvature. 2 of the rays go through F, 1 of them goes through R. So those are our 3 special rays, okay? All right, here's what I want you to do. I want you to draw this, and here's the rule for the first 2 special rays. Light that comes into the mirror straight goes out through the focus and vice versa. So light that goes from the tail through the focus goes out of the mirror straight. Okay, so notice what I've done here. Light that comes out from the cat and goes straight into the concave mirror goes out through the focus, always. And vice versa. So if I send a ray in through the focus, it will come out straight. Notice something. They're going to hit somewhere. Where they hit is the image of that point on the cat, the tip of the tail. Okay? So one rule gives us 2 of the rays. All right? Notice I'm going to go back one. We have 3 special rays. 2 of them go through the focus. Those 2 rays are governed by one rule. Comes in straight, goes out through the focus. Goes in through the focus, comes out straight. Okay? You've got to know that one. It's not anywhere on any sheet for you. All right? Number 2, rule number 2 gives us ray number 3. Light that goes in through the center of curvature, through the radius of curvature, goes out through the center of curvature, or the radius of curvature. I might have just used center instead of radius when I should have. Okay? So I'm actually going to cross that out. The radius, the radius. Sorry about that. Okay, so rule number 2 gives us the 3rd ray. And when we put those 3 rules, 3 rays together, notice we get the tail of the cat and where it belongs. Those should always hit. Okay? So when we make an image, all we're going to do is draw 3 rays. Don't draw any more than that. Just draw the 3, and hopefully they're going to hit each other, and they will come together in one spot and tell you where the image is. So here's what I want you to do. Um, I want you to do the same thing, okay? Use our 2 rules and our 3 rays to do this again, but now the object needs to be between R and F. I'm going to go back one real quick, so hold on. Notice the object was outside of R, okay? It was further away from the mirror than the radius of curvature. This time, I put the object in between. Now, here's a quick little hint for you. Draw it really small. Draw it about like I did, okay? Draw the cat really, really small. So this is a time you need to pause, go over the 2 rules, draw the 3 rays, and see what you end up with, okay? Alrighty, here we go. So I stole this from a book that did a better job than me. So instead of a cat, we have a little brown arrow. All right. Now, in this book, instead of R, they use C for the center of curvature and capital F. All right. But all I'm really interested in is drawing the rays. So ray 1 goes in straight and out through the focus. It should look something like that. Ray number 2 should go through the focus and out. So truthfully, that should be enough to draw the image. And you could stop there on the test if you wanted to. I would suggest drawing one more ray, the one that goes through the center of curvature or the radius of curvature. Now notice on that last one, they had to extend the mirror a little bit because it didn't curve far enough. But here's the point. It goes straight to the mirror, but then it goes out again. So you could just draw it straight from the object out through the center. All right? So notice something. Now the image is upside down again, but it is farther away than the center of the radius of curvature or the center. Okay? So I hope you did okay on that one. And here is your, sorry. Here's not your video lecture problem. Here's something just kind of interesting about these spherical mirrors that we have. If we have a whole bunch of light coming in, all of it will be focused at the focus. Okay, it will all hit the focus. So if I take, a mirror like this, and I point this, pointed at the sun, all the light from the sun is going to be shot into one spot. That becomes very, very bright. These big mirrors like this, you can start fires pretty easily by shining them at the sun. And then the second rule, when it goes through the radius of curvature, a little less interesting, not so much fun. It just bounces straight back out. So anywhere that light is coming from goes right back through that point. So don't need to draw those, just something kind of interesting. Alrighty. So let's review. Couple things. Number 1, some stuff about curved mirrors. Basically, that's radius and focus. Did you get that? Number 2, how do curved mirrors make an image? What we're going to do with those is draw our 3 special rays and make an image with them. Piece of cake. That's all there is to it. There is your video lecture problem. So you're going to draw a mirror again, the focus and the radius. And then I want you to put an object exactly on top of the radius of curvature and draw the 3 rays. And the image you get should be the same size as the object, and it should be upside down, and it should be located right at the radius of curvature. So, see how you do. If you have a problem, come talk to me tomorrow. Have an awesome day. Good night.